These are the ways that students are figuring things out. I also can challenge my students to look at what they're learning through specific lenses. They can think in a metacognitive way about how they're trying to figure things out. And we can tie all this together with a motivation down at the bottom. Why are students trying to figure it out? This is when we present something that they can figure out in a real world, specific personal context, so that they become engaged and become the drivers for their own learning. So in summary, for our NGSS, we want our learning to be three-dimensional, and we want it to be motivating for our students. So here are the three SEPs that we can really focus on to make sure that students are at the center of learning. And these three SEPs have a common thread. We can use these to bring claim, evidence, and reasoning to the forefront of what students are doing. So developing models, constructing explanations, engaging in argumentation, these really work well together to get students thinking about why something is happening and how they can explain it. So we can put this together to think about NGSS instruction in a different way than we ourselves might have experienced science learning. These two shifts look like this. The first is making sure that students are driving the learning to make sense of relevant phenomena. So we can make our learning centered around an anchoring phenomena that motivates students to answer a question or to solve a problem. And the second shift is that three-dimensional learning approach where the teachers are intentionally selecting and sequencing tasks that are student practice centered so that the students can be the ones figuring something out.
All right, so I am going to be going over the next section. I'm Kirsty Hernandez, for those of you that don't know me, but in Young, we're going over that deep clarity of learning goals. So now what we're going to be looking at is that building that precision of pedagogy. So how do we do that? That comes into what we like to call these teacher practices. So when teachers design their science instruction, they may consider what kinds of talk, tasks, and tools do students need in order to fully engage in meaningful forms of science learning. So how can they deeply engage with that NGSS standard performance expectation, all three dimensions that we want them to engage with? So that is where these ambitious science teaching teacher practices come in. And as secondary teachers, if you had an admin come into your classroom and have gotten feedback from them, you may have seen this on that feedback form. So these are the 4 teacher practices articulated by Mark Winchell and others from Ambitious Science Teaching. Ambitious Science Teaching outlines a powerful framework for science teaching to ensure that instruction is rigorous and equitable for students from all backgrounds, which is what the core of NGSS is. It's equitable science instruction for all. The 4 practices are, as you can see in that wheel, 1, planning for engagement with important science ideas, going to eliciting science ideas, supporting ongoing changes in thinking, and pressing for evidence-based explanations. So what we're going to do now is we're going to explore these a little. We are going to put you guys into breakout rooms for about 10 minutes. Once those 10 minutes, or in those 10 minutes, you guys are going to open the note catcher that Lillian has, or In-Young has put into the chat. So there is a note catcher document, and there is also the article that you guys are going to be reading. So you can do this in multiple ways. You can take the first 5 minutes to read through the article, and then as a group discuss how you want to fill it in. You guys can divide and conquer and each take a section and fill it in as a group, but you'll have 10 minutes to do that. and go through the different practices. Okay, are there any questions right now before we move into breakout rooms? No? You can unmute or put in the chat if you do. All right, so Lillian has opened up the breakout rooms for us. So go ahead, you can join a breakout room based on your publisher and grade level. I believe we have everyone covered. If you do not see your publisher, let us know and we will instruct you where to go. If you cannot join a breakout room, please let us know and we'll put you in as needed. All right, everybody, welcome back. So go ahead, you're going to hold on to your note catcher, because as we go through the ambitious science teaching moves, you'll use it to reference back and you can continue to add to it. And we'll show you an example of what that could look like at the end of viewing those practices. So one of the things that comes up as we go through ambitious science teaching is, what is a phenomenon? So this is really where you're looking at planning for your engagement with those science ideas. So a phenomenon is very simply just an event, circumstance, or experience that can be observed by one's senses. I know sometimes we think of it as being this complex phenomenon, has to be super complex and not understandable, but it's really just an experience. Students can develop models and explanations over the course of a unit, and the phenomenon tends to motivate students to explain what is going on. So there's this really cool thing that happens. Why is that happening? How does it happen? What mechanisms are at work? What are, the atoms or cells or the smaller units doing to make that thing happen? So it requires students to draw upon a range of science concepts, and it necessitates engagement in multiple investigations and learning activities. This is not a one-shot, we're going to understand the phenomena in one lesson, one period, and we're done with it. So the phenomenon is tied into an NGSS storyline. And that's where the connection back to those 3 dimensions of NGSS are. So we have, this is what's called the backbone of a unit storyline. And using an anchoring phenomena, that thing that, the whole unit is tied back to, that launches this investigation into the unit, and students develop initial explanations or models. Oftentimes, these explanations might be oversimplified and short, but students should be encouraged to demonstrate their thinking as best they can at that moment. They are not supposed to know everything in that initial model or explanation. Teachers then plan to support students' ongoing changes in thinking and provide deep clarity of those learning goals and those 3-dimensional standards. You'll notice part of the unit storyline includes opportunities for students to revise their explanation. So it's not just we're thinking about this initially, we're never coming back to it, but this repetitive, okay, we've learned things, how has your thinking changed? And students continue to build their knowledge to construct those gapless explanations using evidence to support the claim about the phenomena by the end of the unit. So now I'm going to hand it off to Lillian, who will take us through the practices.
Yes. Hi, everyone. I'm Lillian, and I'm the instructional coach for the Huntington Park, Walnut Park, and Vernon community of schools. And so we're going to take a look at a 2nd grade class engaging in a phenomena-driven unit. And although it is a 2nd grade class, it's focused on the practices and what the teacher is doing. And so in this segment that we're going to be looking at, the content will be Earth system processes that shape the Earth, and you'll notice the DCIs are Earth science. And the phenomena is what caused the town of Moncton to flood. You will notice that the science and engineering practices that students will be engaged in are developing and using models, constructing explanations and designing solutions, and engaging in argumentation from evidence. So in this case, the phenomena is the flooding of this town called Moncton. So as you watch the video, you can reference to your the reading that you did or to the wheel of the 4 practices. So if you can identify what teacher practices or teacher moves are evident in this video.
So we've been investigating the town of Moncton, and we've been wondering and investigating the question, what caused the town of Moncton to flood?
The soil was faster, so the water could go through the glacier moraine to the town of Moncton.
So I heard there's a claim, and I heard some evidence. Can I have someone repeat what you heard? What was the general claim that you heard?
What you see in the video today is young kids weighing multiple hypotheses, checking each other, doing some fact checks, and trying to get to the heart of what part of my statement do you agree or disagree with.
The project that we are working on is really thinking about what certain scientific practices that are central to NGSS look like when working in primary classrooms, so in grades kindergarten through 2nd grade.
What claim did you hear?
I heard that if the glacier had mostly sand and some pebbles in the mountain, then the water would go slower.
Then the water would go slower. Do you agree or disagree?
Agree.
Can you tell me more?
Because when we did the experiment with earth materials and we used sand, it went slower than soil, like pebbles. And I want to add on. Yeah, I want to add on to Jamie's. I agree with it is very compact and it has little tiny spaces in between for the water to go through. But I really think that sand went the slowest because sand has the most littlest things in it.
This video looks at a whole unit of instruction and how teachers can support scientific argumentation inside of modeling at the beginning, middle, and end of a unit.
So we've been
Okay, so take a moment and just think about how did the teacher plan for engagement with the phenomena? Feel free to type something in the chat or unmute yourself. What did you notice as far as the how did the teacher plan for engagement? Was there evidence of an important science idea? So Ms. Hamimi says revising the hypotheses, and Ms. Vasquez says the use of visuals to introduce that phenomenon. And Boris says they did an experiment. They conducted some form of experiment. Great, thank you. And Emily says any student is able to, oops, I just missed it, popped up. Any student is able to contribute based on observations and images. Great, so they're valuing the students' ideas. Guide the students with questions, speaking opportunities. Excellent, thank you so much. Okay, so we're gonna move on to another segment. And again, we're gonna see if we can identify what teacher moves, which of the 4 practices we might see, either from 1 through 4 in this following segment.
Started with drawing our initial models and talking about our own ideas and personal experiences about what we think caused the town to flood. At the beginning of the unit, the students are presented with the phenomena and they're given a model to be thinking about how and why the town had flooded. And so as a teacher, I'm listening to students' ideas, listening to their own language that they're bringing.
His idea was that water was going through the ground, and then there was like a layer of stone up over here, and then the water kept on rising up.
Our model is that maybe the dam exploded because there's such a powerful water current.
Their initial models don't necessarily have a lot of writing, so it's important that you're listening to the students' ideas. Yesterday, you shared your initial ideas of what you think might be happening that's causing the flood for the town of Moncton. And so I have 3 claims that I want to share with you, and I want you to think about them to yourself on whether you agree or whether you would like to make any changes or if you like them just the way they are. So one of the claims we have is, it says, we claim that the water filled up behind the dam and went up the hill and then down to the town. And so I have made copies of the models that showed that idea. Once I had seen those patterns, we presented the claims and asked students to see if they agreed or disagreed with those claims, if they wanted to make any revisions, and had their models where we felt it represented those claims. So she was saying this model should be over here.
Yeah.
Are you agreeing with that? So this model was in the wrong section.
I think there are a few considerations that are important in selecting key claims at the beginning of a unit. That's to anchor modeling and really explaining a phenomenon. The first step that Kitten engaged in was really looking at the range of student models when they first initially thought about what caused the town of Moncton to flood. And so she was trying to select out what are some of the ideas she's seen across models that were common, that were familiar to students, and that also represented a range of perspectives that they'd be able to pursue together over time. Kids come in with a range of really productive and sensible ideas and experiences from their lives. Even young students are coming in with a wealth of experiences, and those are what are particularly generative for supporting their sense-making.
Share your idea again, and I want everyone to think about where does this idea go, this personal experience. So hold on, put your hands down, and let's share that story one more time.
So me and Andrew were using those tools, and we pushed the water off the concrete, and so then it soaked inside the soil.
So this is an idea that would agree and support this claim. Okay, we might have some that you would disagree and have some kind of experience that would say that can't happen.
Okay, so which of the practices did we notice was most prevalent in this segment? Planning for engagement, eliciting student ideas, supporting ongoing changes in thinking, or pressing for evidence-based explanations? 1, 2, 3, or 4. We're seeing a strong, a lot of eliciting. 2 and 3, 2 and 3. Great. Ruben says modeling techniques, eliciting student ideas that led them to their claims, exchanging students' ideas that leads to changes in thinking. Fantastic. Marta says 2 and 3. Romina says eliciting student ideas. Fantastic.
With drawing our
to another segment and see if we can identify.
So we use the claim T-charts to collect evidence and thinking about the evidence that we are using, whether it proves or disproves that claim. Then as students built their knowledge, they started using other pieces of evidence in the experiments that they've done, the videos that we were watching, the texts that we were reading. And so building that over time, students became more confident in their science ideas. Some students changed their science ideas because of those experiences. We're going to be shopping for evidence today, and you're going to be thinking about these 2 claims on whether they help support or disprove these ideas.
They make claims at the beginning of a unit, and then they constantly revise them over time. And they're amounting evidence and weighing evidence throughout the entire unit. But it's all done within the drawing of a scientific model. And they're constantly revisiting and drawing what they can see and what they can't see.
So which ambitious science teaching practice was evident in the video segment we just viewed? And how do you know? Thing 4, pressing for evidence-based explanations. We're seeing Martha with a 3, 4. Ruben says abundance of evidence to support their claim, pressing for evidence-based explanations. 3 and 4, 3. Asking for evidence. Great. So in this case, we saw we did see evidence of both. And this segment was focusing mostly on supporting ongoing changes in thinking. Okay, we're going to look at the 4th segment of this unit.
Tell me your claim again.
If the glacier left mostly sand and some rocks in the mountain, then the water would go slower to the town because sand collects the water when the water passes by.
Do you agree with that? So the next step is I want you to be thinking about evidence. We've been talking about evidence. And so how do we know that? So I know this because what I'm hearing you say is that because they're so close together, that it's slowing it down so making it go slower. Is there an example where we saw that because it wasn't so close together that it went faster? Was there a different material that?
Well, I think it was with pebbles.
So we can look to see too, right? Is there? So was that
The pebble. Well, clay was 100.
Did that take longer or shorter amount of time?
Long.
Yeah.
They're usually modeling and argumentation together. And in that way, these practices co-develop, where they get better at scientific modeling and drawing what they can see and what they can't see, along with developing much richer scientific claims over time.
Tell me your claim again.
Okay, so in this segment, what practice did we see?
That's
4, pressing for evidence-based explanations. I'm seeing 4s all down the chat. Great. And if you notice, the teacher was the one pressing for that evidence, and she even referred to that chart on the wall for them to look at the evidence that they had gathered throughout their investigation of the flooding of this town. We're pressing for evidence-based explanations. Okay, and then here's just one final 5th segment, and it's showing how the teacher concludes a unit. You will see evidence of several teacher practices. And again, we want to emphasize the importance of discourse in science and argumentation. The scientific argumentation was successful because the class continuously worked on discussing. They did build, the teacher had norms established, and there was a sense of community and trust.
We do a lot of thinking about how scientists is not just usually one person, and that is a group of people working together as a community. And so we spend a lot of time at the beginning of the year talking about what does that look like and what does that sound like. It's not quick at all. Yeah, it takes time. So what are you hearing Jamie
I
saying?
heard Jamie say that he thought that the sand was going to, I actually can't remember now.
So what can you do?
Can you please repeat it, Jamie?
I agree with Nick's idea because the sand is more packed together than the pebbles. There aren't as many holes in the sand.
Yeah. And I agree with that idea.
I feel like they've changed in having the confidence of being able to share their thinking and agreeing and disagreeing comfortably. I see them now challenging each other and thinking about the ideas that they share and asking really good questions or clarifying What do they mean by that? I want to thank you for sharing and taking a stand today. And we'll continue thinking more, yes, and we'll continue thinking more about what's causing this. So nice job today. Thank you.
And so as Kirsty mentioned earlier, here is in the slide, you see examples of possible evidence in each of those 4 practices. And so just understand that as teachers engage in these 4 practices, it's not just in a linear direction, they may have to revisit the practices based on the student learning and their assessment. So take a moment and think about in what ways do the purposeful use of phenomena and the practices work together to support student learning? Okay, Ruben just shared and asked in the chat, additional question to ask students at the end of the assignment, was this a good place to build a town? If it rains hard again, could this town be flooded again? Yes, good question. And this could turn into some kind of engineering, perhaps, challenge or unit. And yeah, so that's for the next part, taking it further, definitely. Thank you, Ruben, for sharing that. Okay, and now we're gonna send it back to Kirsty for the next portion.
All right, so based on just timing, what we're going to put you into breakout rooms for maybe about 7 minutes. In your breakout room, you know what, Lillian, I'm going to start sharing my screen so I can share. We're going to send you to breakout rooms with this note catcher. It has all 4 of the possible publishers for secondary. It is not content specific. It is just the publisher specific. So you'll find your publisher. And when you go through it, this kind of breaks it down. It gives you what a sample storyline would look like. So you have an Amplify sample, HMH sample, Savas, oops, I don't want to do that, Savas and Discovery. So there's your sample. From there, we have this tool where you call out the phenomenon that are listed for whatever your next unit of study is. So you may not be in Bio Unit 1, and that is, you may be in Bio Unit 3 or 2 or wherever you are, and that is completely fine. But you want to call out that unit level anchoring phenomenon, and then each concept or each investigative phenomenon after that. If you need help accessing your materials for any reason, we have also included this for you. And going from there, you can also, there's lots of background noise right now. You'll see where you can see the unit information. So the unit overview, and then you have your instructional segment planner or storyline with HMH there. Every, except Amplify. Amplify tells you where to look for it, where you can see it in your, once you're on Amplify, but HMH and Savas and Discovery all have little bit of more guided instructions for where we found these like storyline or kind of instructional segment documents. So maybe 5 minutes now in your breakout rooms, just for you to explore that a little bit.
Yeah, go ahead and open up the breakout rooms.
Are they supposed to be by grade level?
They could be, but they could just be by publisher as well.
Lily, on the HMH book,
Yeah.
I have some difficulties. Maybe I just don't know how to do it. Like I go to a place, I get to a chapter, but if I want to go back to another unit, it seems like I have to like check out all together and come back to it. Is that just how it is?
Yeah, if it opens up in a separate window, yeah, then you would have to, yeah, go
Yeah, well,
back.
that's
It's in
what
a
I do. I
sense kind
thought
of
it
like
was-
start over. Yeah.
Yeah, and that's kind of a drag. I wish it wasn't like that, but
Yeah.
it is what it is.
I
But
know.
okay, sounds good. Let me
Yeah.
go in my room. Thank you.
Okay. Uh-huh.
James, what? Oh, he's gone.
Okay, so she said about 5 minutes. I didn't set a timer.
Hi, Rhea.
Mr. Mimi.
Hi. I think the instructions were unclear for our team.
Okay, I'll go in there and help you out. Or Kirsty, do you want to go?
It's up to you. It's just exploring. Just explore.
it's
Look at it. How
explore.
could you use it?
Is
Yeah.
there a link? I've seen the storyline
Oh.
before, but are we supposed
Did we put the link at the? No, we didn't put the link to the note catcher.
Oh my
Oh.
goodness. No wonder.
no.
Sorry.
Okay.
It's our
Okay.
fault then.
Oh
Then,
no.
then you talk about
But
how
I've
you
s-
could use phenomenon. Yeah, look at that question that was asked about phenomenon. You guys can discuss that.
Okay.
Okay, so we have to go to the rooms and drop off the links.
Yeah.
The link. Okay.
Okay, where's
I'm sorry. I didn't see how we were skipping ahead and I didn't remember where we were.
oh, that's okay. All right, so I'm gonna go to chemistry.
Okay, I'll go to
Savas chemistry.
Amplify.
Okay. I'll go to Savas chemistry, then HMH bio.
Or you know what, at this point, that's gonna let's maybe give it when they come back and just let them talk whatever they're talking about. Cause
I'm gonna still drop it off. I'll be back.
okay.
Hi, sorry, we forgot to give you the link to the doc. Oops, that's not it. That's all of your email addresses. So sorry. Okay.
No worries.
Here's the note catcher.
Oh, but you know what? The link to the note catcher is also for Christmas. My daughter still talks about them